All right, up next, let's talk about factoring by grouping. So our steps for factoring by grouping: first, factor out a GCF, make that first term positive. So we always want to deal with positive first terms. After we do that, we'll group the first two terms together and the last two terms together using parentheses. Factor the GCF out of each of those groups, and again, we'll want to make the first term in each group positive. And then factor out a common binomial. All right. So up first, we've got x cubed plus 7x squared plus 4x plus 28. When we're looking at this, we look at the numbers 1, 7, 4, and 28. We aren't going to have a GCF for this whole thing. So we're on to the next step already. And our variables, we don't have a GCF because there's no x here. Group the first two terms together and the last two terms together using parentheses. So these first two terms, we've got x cubed plus 7x squared plus 4x plus 28. So our first two, x cubed plus 7x squared. What do they have in common? Our GCF here, we don't have, for the number, we have a 1 and a 7, so we aren't going to have anything to do with that. But for our variables, we've got an x cubed, so 3 x's, and we've got an x squared, so 2 x's. So that means our GCF is going to be x squared. And just like before, we're going to write that out in front, and then it's going to be like we're dividing by that. So you're dividing by that GCF, and you're pulling it out in the front. And then what's left over? X cubed divided by x squared. So 2 of those x's are going to cancel out. We're going to be left with just 1x. And then 7x squared. The x squared is going to cancel out, so we'll just be left with plus 7. All right, now for our second group, maybe I'll do this in a different color. We're looking at 4x plus 28. Our numbers, so for our GCF, we're looking at the numbers first, 4 and 28. We can pull a 4 out of 28, so it's going to be a plus 4 coming out. And then what's left over? 4x divided by 4 leaves us with just x. 28 divided by 4 leaves us with a plus 7. All right, and now we know that we've done this correctly. We know that we were able to factor by grouping if when we get to this point, we have the same thing inside of these parentheses. We have the x plus 7 inside both of these parentheses. So this is our common binomial. And when it says to factor out our common binomial, you can think of it as pulling this x plus 7 out in the front and writing what's left over. And what is left over is this x squared and this plus 4. And so we have successfully factored by grouping. All right, let's try another one. So if we have negative 4n cubed minus 6n squared minus 14n minus 21, our first question for ourselves, do we have a GCF? And we know we want to make that first term positive. So if nothing else, we're going to be factoring out a negative 1. So I'm going to go ahead and write a negative because I know I want to pull that out. 4, 6, 14, those are all even, so I could pull out a 2. But as soon as we get to 21, we can't pull out a 2 anymore. So I think with this one, we're just going to have to factor out a negative 1. And when you're factoring out a negative 1, what you're going to leave behind is just the opposite of all of these. You're just going to change all of these signs. So to factor out a negative just really tells you to change all of the signs. So negative 4n cubed is going to change to positive 4n cubed minus 6n cubed, or 6n squared, so that'll be plus 6n squared, minus 14n, that'll be plus 14n, minus 21, that'll be plus 21. Okay. And now we don't have a GCF here. We made our first term positive, so now we can factor by grouping. We're going to group those first two terms together and those second two terms together. And we're going to see what we've got. And by the way, we're just going to carry this -1 along for the ride out in front of this whole thing. So I'll just go ahead and set up so that I can do all of my work inside of these parentheses. All right, so then we're looking at 4n cubed plus 6n squared. So the largest number that we can pull out is a 2. 4 and 6 share a 2. And the largest variable we can pull out is an n squared. We've got 3 n's here, 2 n's here, so we can pull out 2 of them. Pull out that 2n squared. And what we're left behind with, 4n cubed divided by 2n squared. 4 divided by 2 gives us a 2. And n cubed divided by n squared. 2 of those n's cancel out, so it leaves us just with n. 6n squared divided by 2n squared. 6 divided by 2 gives us a plus 3. And then n squared divided by n squared, those cancel. We're just left with the plus 3. All right, now we do the same thing for the other group, 14n plus 21. So when we're looking at this, 14 and 21 both have a 7 in common, so we're going to pull that 7 out front. And we don't have an n in common. This has an n, this doesn't. So we're just going to have to leave the variable part alone. 14n divided by 7 leaves us with 2n. And 21 divided by 7 leaves us with a plus 3. And now again, we have this common binomial, that 2n plus 3. We know we've done something right when we get the same binomial in these two. So let's go ahead and pull that out in front and not forget our -1. So we've still got that -1. And then we've got this 2n plus 3. And then what's left over, we've got that 2n squared plus 7. 2n squared plus 7. And we write that together in one set of parentheses. And so then we have successfully factored by grouping. Okay. So we learned factoring by grouping before we learn factoring quadratics using split the middle, because this technique we're going to need to do some factoring by grouping in it. And so this is what we do if we have a quadratic. So again, that's the highest exponent on a variable is a 2, a quadratic with a leading coefficient other than 1. So we know how to factor quadratics if the leading coefficient is 1. If it's something other than 1, then we've got a bit of an extra step here. You'll see it's not too bad though. We can do this. All right, so if possible, factor out a GCF, make the first term positive. We're going to do that every time for pretty much all of the factoring we do. It always helps to start with something positive. All right, multiply the first coefficient by the constant term. This is going to be what you're trying to multiply to in your product sum chart. And then find two factors of this product that add up to the middle number. Split the middle based on these two factors, and then we'll have 4 terms, and we can use that grouping technique. So let's get into it. So if we have 4n squared minus 17n plus 4, maybe I'll do the product sum chart a bit lower this time. Let's see how much space I have. Okay. All right, so we're looking at that first term and that last term. So the leading coefficient times the constant term. 4 times 4. So we want to multiply to 4 times 4. Off the screen. We're going to multiply to 4 times 4, which is 16. And we want to add to that middle term, add to our b, which is negative 17. So if we're thinking of numbers that multiply to 16 and add to negative 17, well, if they're going to need to add to a negative, then they're both going to need to be negative, right? So maybe first we think, how about negative 1 times negative 16? That multiplies to a positive 16. Negative 1 minus 16 is going to give us negative 17. And if this didn't jump out at you immediately, that's why we do the product sum chart. You can try a few things and eventually you'll get to this. So here are our numbers, negative 1, negative 16. But instead, this time we can't just write it. We have to use these two factors to split the middle. That's why we call this split the middle. And so this negative 17, instead of writing it as negative 17n, we're going to write it as minus 1n minus 16n. The rest of this equation is going to stay the same. So we're still going to have this 4n squared out in front and this plus 4 in the back. And now we use this factoring by grouping technique to finish this off. So we're going to group our first two terms together and our second two terms together. Make sure you keep this negative with the 16. So the sign matters. Up here, it didn't matter so much because it was a plus. If it's a negative, make sure you're keeping that sign with it. All right, so if we're looking at 4n squared minus 1n, our greatest common factor here, the numbers 4 and negative 1, that's not going to do much for us. So our greatest common factor here is just going to be that n. We'll pull that n out in front. And then what we're left behind with, we'll have 4n squared divided by n, so that'll just be 4n. One of those n's is going to cancel out. And then minus 1n divided by n, that's just going to leave us with a minus 1. Remember, when you factor out a GCF, you need to end with as many terms as you started with. So we wouldn't want to just get rid of this and say it cancels out completely. We really need this minus 1. All right, and so then when we're looking at our second group here, this plus 16n or this negative 16n plus 4, negative 16n plus 4, we want to make the leading term in this group positive. So if we have a negative here, we're going to need to factor out a negative. So the greatest common factor between 16 and 4 is going to be 4, and we're going to factor out a negative 4. So then that'll be minus 4 coming out in the front, and then what we're left behind with, negative 16n divided by negative 4 gives us positive 4n, negative 16 divided by negative 4. The negatives cancel out, we're left with something positive, and then n is just going to stay since we don't have a variable here in our GCF. Plus 4 divided by minus 4. So that's going to leave us with minus 1. 4 over 4 gives us 1. And since one of them is negative, it's going to be negative. All right. And again, we've done this successfully because we have that common factor, that 4n minus 1. Sometimes you'll be off by a negative. It'll seem like things are close to adding up right, but not quite. In that case, you probably forgot to factor out this negative here. You can go back, fix it, and you should be able to get to where you're going. All right, so then pull that 4n minus 1 out, and then we write what is left behind, that n minus 4. And we have factored a quadratic with a leading coefficient other than 1. All right, let's try another one. 3k squared minus 5k plus 2. All right, so again, we're going to start with that product sum chart. We need two numbers that are going to multiply to give us 3 times 2. So we're looking at that first and last. 3 times 2 gives us 6. So we need two numbers that are going to multiply to 6 and add to that middle, negative 5. So if we're thinking about this, maybe at first you say, okay, how about, I know I need to add to a negative, and I need to multiply to a positive, so that's going to be two negative numbers, maybe -1 and -6. -1 times -6 gives us +6, so that works, but -1 minus 6 gives us -7. So this does not quite work. This is a common mistake here. So be careful with the 6 and the 5. How about -2 and -3? -2 minus 3 gives us -5. So these are going to be our numbers. But remember, since we have that leading coefficient other than 1, we can't just write these, plop these in like we did when we had that leading coefficient of 1. We have to use these two to split the middle. So instead of -5k, we're going to be writing -2k minus 3k. And by the way, the order here doesn't matter. It'll change the way your work looks, but it won't change your final answer. So if you're working through this with someone else and they write this in a different order, don't worry, you should get to the same answer in the end. Okay, so then we bring down those other terms and we group. Group. All right, and so now we've got 3k squared minus 2k in our first group. All we can factor out here is a k. So we'll pull that out in front. Maybe I'll separate this a little bit. Pull that out in front. And what we're left behind with 3k squared divided by k. One of those k's cancel out, so we're left with 3k minus 2k divided by k minus 2. And then in this second piece here, 3k, or -3k plus 2, we know we want to make that first term positive, so we're going to be factoring out a -1. But other than that, there's nothing we can do. The 3 and the 2 have nothing in common. The k is just only in one of them, so we're just going to be factoring out a -1. So we'll write that -1, and then times, just switching the signs here, positive 3k minus 2. All right, and again, we know we've done it right. We've got that common binomial, 3k minus 2. And so we can pull that piece out in front and write what's left behind. So that k and that -1. And we have factored by splitting the middle. All right, and we've got one more. -15x cubed plus 33x squared minus 18x. All right, and so far we haven't had to do this first step, this factor out the GCF. But when I look at this, I notice, I'm like, okay, hang on. So my greatest degree actually isn't a 2, and this -15, this 33, this -18, they all share a common factor, and also I want that first term to be positive. So maybe all of these things are telling us we should probably be looking for a GCF. So let's think about this. So if we have -15 x cubed, positive 33x squared, and -18x, the greatest number that all three of these, 15, 33, and 18, have in common is a 3. 33 is maybe an easy one to start with because you're like, well, 33 is only 3 and 11, so it has to be one of those two if there is a GCF. And as it turns out, it's the 3. 15, 33, 18 all share a 3. They all share a 3, and I'm going to make it a -3 because this leading coefficient is negative, and I want it to be positive, so I'm going to pull out that negative. And now when I'm looking at the variable portion, I see, okay, we have an x cubed, an x squared, and an x. So I can pull out one of those x's. So let's write that out in front, that -3x, and then let's see what we're left behind with. negative 15x cubed divided by negative 3x. Negative 15 over negative 3, that gives us a positive 5. X cubed over x, that gives us an x squared. On to the next term, 33x squared over negative 3x, 33 over negative 3, that gives us a minus 11. X squared over x, that gives us an x. One of them cancels out, we're left with just one of them. Negative 18x over negative 3x, that gives us a plus 6, and the x's cancel. Okay, great. Now we have something that looks a little more like what we've already dealt with these. All right, so then we want to, now we can start our product sum chart. And we're not going to concern ourselves with this negative 3x. It's just going to, once you factor out a GCF, it's kind of just going to hang out. It's going to be along for the ride while you do the rest of what you've got to do with this leftover portion. So we're going to want two numbers that multiply to give us 5 times 6. So we're looking at that first times the last. 5 times 6, which is 30. And add to give us that middle term. Negative 11. So this is our B now, negative 11. All right. And if you're still having trouble seeing these, keep working on these product sum charts. But this one, we're going to be looking at negative 5 times negative 6. Negative 5 times negative 6 gives us positive 30. Negative 5 minus 6 gives us negative 11. So we're going to use that to split our middle, negative 5x minus 6x. Don't forget to keep that x with it. 5x squared comes down, plus 6, that comes down. And now we can group. So we're going to group those first two together. Going to group those second two together. And look for our GCFs. Now remember, we have the GCF on the outside that's multiplying this whole thing. So we're going to keep it on the outside with that whole thing, at least for now. When we're looking at this 5x squared minus 5x, we can pull out a 5x. And what will be left behind with 5x squared divided by 5x is just x. Minus 5x divided by 5x is just minus 1. Looking at this second piece, negative 6x plus 6. We want this to be positive. Remember, the leading term of that second group, we need that to be positive also. So we're going to pull out a negative, and then we can pull out a 6 as well. So we'll pull out that negative 6, and we'll be left with x minus 1. And again, we know we've done it right when we get that common binomial, that x plus 1. So we're going to have this negative 3x out in front. We'll have that x minus 1. And then we'll have the leftover portion, that 5x and that minus 6. And that we have factored using split the middle. Okay. We've got one more type of factoring, so let's go ahead and do that before I end this video. So our last type of factoring is the special case of the difference of squares. And so this, if you can recognize these, it's really going to save you some headache. So this is, let's think about what this means. So a difference, that means that there's a subtraction happening. So this only applies when you have something that is being subtracted. You'll notice in my two examples here, we have the minus 9, the minus 25. We have subtraction happening. And these squares, that means that each of our terms are going to be squares. 9 is 3 squared, 25 is 5 squared, 4 is 2 squared. Okay, anyway, and we can only use this if we're missing the middle term. In other words, that you have no like bx part. The part that has just an x with it, you're missing that part. So if you only have the square and the constant, then that's when you can use this, if you have just the square and the constant. Okay, so a quadratic equation that is a difference of squares is of the form, we'll write this as a squared x squared minus, we'll call this b squared. I don't know, I'm just picking variables here. This isn't the same a and b as before, but that's okay. And we can factor this as ax plus b times ax minus b. So we just split it up, we get rid of all these squares, and we have one that's plus and one that's minus. And this is going to save us a lot of headache of having to do the split the middle, or, you know, trying to figure out what that middle term is, that whole ordeal. So if we have x squared minus 9, well, we don't have a coefficient here, so we don't need to worry about that part. In fact, if you have just x squared minus b squared, then you can write that as x plus b, x minus b. So all I'm going to do here is I'm going to recognize that this 9 is a square. It's 3 squared. So x squared minus 3 squared. And then we can kind of use this formula. We split it up. X plus 3, x minus 3. And we factored it. And now many of you won't need this middle step. If you recognize 9 as that 3 squared, you can go straight from here to here. X squared minus 9, that's x plus 3, x minus 3. These are going to come up quite a bit, so be ready for these guys. All right, and if we have 4 squared minus 25, well, all we've done is we've added another square in here, but that's fine. We can write this as 2 squared times x squared minus 5 squared. So rewrite those, those numbers as squares. And now we drop those squares off. We write it as 2x plus 5 times 2x minus 5. And we have factored it. And if you know how to FOIL, you can test this, FOIL it back out, and you'll see that you get back to where you started. If you don't know how to FOIL, we'll briefly cover that here soon. Okay, so that's what we've got for factoring. If you still need extra help factoring, please view some of the resources on the Blackboard page or come talk to me. And next up, we'll get into radicals. That should be a much shorter video.